So how to program the ATP sequences? The first parameter that you need to program is the type of ATP sequence. You have the choice between the burst, a ramp, and a ramp plus. We already have explained what was a burst and a ramp. For the ramp plus, this is a specificity of Medtronic devices. A pulse is added to each sequence, reducing the length of intervals for the 3 first pulses and then remaining constant thereafter. The second parameters that you will need to program is the number of pulses per sequence. 8 to 15 pulses are usually programmed in each burst. If the number of pulses is insufficient, they might not penetrate the tachycardia circuit and remain ineffective. On the other hand, if the number is excessive, the sequence might end but then re-induce the tachycardia. An additional pacing stimulus is systematically added between each sequence. You will have to program the coupling between the different pacing intervals. The ATP pacing interval is based on the ventricular tachycardia cycle length, which is calculated as the average of the last 4 ventricular intervals preceding the VT detection. For a burst, it is usual to program a percentage of 84% or 88%. If you program a 10 milliseconds interval decrement, it means that if the first burst is inefficient and if the rate of the tachycardia does not change, then the second burst will be faster than the first one of 10 milliseconds. You need then to program the number of sequences of ATP. The number of programmed sequences varies as a function of the rate of the tachycardia. For tachycardia of less than 180 beats per minute, for example, a large number of sequences can be programmed in order to delay to a maximum the shock delivery for a tachycardia that does not threaten the patient's short-term survival. So, depending on the centers, for tachycardia between 150 to 180, it is usual to program 3 to 6 consecutive sequences of ATP. The smart mode here will disable a ventricular ATP therapy that has been unsuccessful in 4 consecutive episodes so that the device can treat subsequent episodes more quickly with therapies that have been effective. There are some additional parameters that you can program for the different sequences of ATP. For example, there is a minimum ATP interval. Here is 200 milliseconds. It means that there is a rate limit beyond which, regardless of the programming, the device will not pace. If, for example, during a ramp, the minimum interval of 200 milliseconds has been reached, the following cycles will be paced at that minimal coupling cycle length without further decrement. The ventricular amplitude, the ventricular pulse width, and the ventricular pace blanking are the same for all ventricular ATP therapies, but are programmed separately from the bradycardia pacing pulse width, amplitude, and pace blanking periods. You can also change the stimulation site for ATP. Changing the site of stimulation may modify the ability of a pacing impulse to interact with the tachycardia circuit and terminate it. In single and dual lead ICDs, of course, the only possibility is RV pacing. In contrast, CRT devices offer the potential for alternate pacing sites, and ATP delivered from the left ventricular lead or with biventricular pacing may increase the success compared with pacing from the right ventricular lead, since many reentrant circuits rise in the LV walls.